No. Ready?
Oh.
Dear Six Flags.
This is our roller coaster, the Natural Selector. It is 100 meters tall using increments of 10 meters per unit, and it is 350 meters long, completely reasonable for a roller coaster. It has a lift, getting up to 100 meters tall, and then 5 distinct curves and a loading zone that are all completely gravity driven.
The roller coaster is a completely jerk-free ride, and it has many various changes in acceleration for the thrill seekers of the world.
In addition, this coaster has the humps and the bumps to leave our clientele satisfied. The purpose of the Natural Selector is to improve the human race by removing the weak from the strong.
Hence the name, the Natural Selector.
As Nick said before, this coaster is completely gravity driven. Gravity allows us to calculate the gravitational potential energy, which is the driving source for our coaster. Gravitational potential energy is calculated by multiplying height with mass and gravity. So the gravitational potential energy will be higher at the absolute and local maxes relative to the rest of the track. To find gravitational potential energy at each point, we must determine the dependent variable in the situation, which is height. So, as you can see here, and what I just said before, gravitational potential energy is equal to mgh, mass, gravity, and height. So the mass of our cart plus the people on average is about 2,000 kilograms. Gravity is always at a constant of 9.8 meters per second squared, and the height is our dependent variable. So at our first absolute mass, which is located right here, the mass is 2,000 kilograms. The gravity is 9.81 meters per second, and the height is 100 meters. So that comes out to a energy of gravitational potential energy of 1,962 kilojoules. And as you can see, for the next local max, which is located right around here, the gravitational potential energy is 1,750.104 kilojoules. And then at the next local max, which is right around there, the gravitational potential energy is 1,526.436 kilojoules. Gravitational potential energy is the source for the rest of the energy that will be used on the roller coaster. And so for more on that, here's Ambesh.
Thank you, Bobby. Now let's talk about the other energies that are present throughout the roller coaster. Kinetic and potential energies are conserved. For the sake of this coaster, we're going to say heat, sound, and frictional energies are negligible. At the absolute maximum, right here at 100 meters, the potential energy is at its max, and the kinetic energy is at 0. At the absolute minimum, over here, at 0, the potential energy is at 0, and the kinetic energy is at its max. As the riders travel up the humps and bumps, the kinetic energy and potential energy, the kinetic energy transfers into potential energy, and the potential energy transfers into kinetic energy, and vice versa. Now let's look at an animation. As we can see in the animation, the riders are at the loading dock right now where there's no energy present. Once they take a ride up to once they go up the lift and they're at the absolute maximum, their potential energy is at a max and there is no kinetic energy present. Now they will travel down the hump, and they're not at the absolute minimum, they're at a relative minimum right now. So there's still some potential energy present, but most of it is kinetic energy. And once they travel through the loop-de-loop, which is not present in our roller coaster, they will reach the absolute minimum, where you can see the potential energy is 0 and the kinetic energy is at its max. Now let's go back to our roller coaster, and let's look at some calculations. Now let's just look at the calculations. At the absolute maximum, The kinetic energy is 0 because the velocity is 0, canceling out the rest of the equation. The potential energy at height 100, which is the dependent variable, turns out to be 1,960 kilojoules. At the relative minimum, the kinetic energy is 552 kilojoules, and the potential energy is 1,407.28 kilojoules. Both of those added up together equals the initial 1,960 kilojoules of the potential energy, proving that energy is conserved throughout the roller coaster. And for the relative maximum, the kinetic energy is 111 kilojoules. 211 kilojoules. And the potential energy is 1,748.32 kilojoules. Again, added up equals the initial 1,960 kilojoules. Now let's move on to Nick while he explains why this is happening.
Thank you, Anvesh. So now we're going to see why this really matters. We're going to take a look at this section of the graph because that is where the highest changes in velocity and acceleration occur. And we've calculated them over here, but that doesn't matter too much. So we're looking at it here because the humans experience the most forces there. So using the potential energy and kinetic energy equation from Anvesh, we know that energy is always conserved, so 1/2 mv squared equals mgh. From that, mass cancels, and then you figure out what velocity is. Velocity equals the square root of 2gh. But h is really 100 minus h because we're trying to find the difference in initial height. So what we want to do next is find the velocity at the minimum right here. So at the minimum, we take the square root of 2 times 9.81, which is gravity, times 45.8, because this point right here is 45.8 meters down from the original point. So through those calculations, we get that there is a velocity of 29 meters per second. But that, because this is the minimum, and at the minimum the slope is completely flat, that is all headed in the horizontal direction. So the roller coaster at that point is 29 meters per second, directly horizontal. Next, we want to take the velocity at this point, which is completely vertical because we have a cubed root graph in our roller coaster. So using that, the point is 35.9 meters away from the start value. So plugging that in, we get that the velocity is 27 meters per second. And that is completely vertical because the graph is completely vertical at that point. But how does this work when the graph is not either horizontal or vertical? How do we find the horizontal and vertical components of the velocity at any point on the graph? Well, that's what we were trying to figure out. So we have here the velocity equation. The square root of 2 times 9.81 times 100 minus f of x. And f of x is just the height because that is whatever the y value is at that certain x value. So I drew the little curve, our fourth curve. So down here is the minimum we just talked about, and up here would be the vertical point. So I'm just using a point right here in between those 2 points so we can use it as an example. So the tangent line at that point is in line with the slope, which the slope is f prime of x. So using a triangle like this, we have the rise and run, which we can find using the slope. So if we plug in an x value for f prime, we get a value over 1, because the ratio of any value f prime gives us is just that number over 1. So using that, we get a triangle down here where the rise is whatever value f prime gives us, and then 1 is always the run. And so we're going to use that to figure out the angle in there. So using an x value of 23, because 23 is in between this minimum and that vertical point, works out easy that way, we get that f prime is 1.59. So next we take the SOHCAHTOA rules, tangent equals opposite over adjacent. So we get tangent of x equals 1.59 over 1. Working through that with math, x equals tangent negative 1 of 1.59. So then the angle in this triangle right here is 57.83 degrees. So here's Mike on why this makes any sense at all.
Thanks, Nick. Now on to the next step. So, through differential calculus, we found that the angle is 57.83 degrees. Now, at x equals 23, the velocity, through calculation, is 29.04 meters per second. And so, in order to find the horizontal and vertical components of velocity, we need to use trigonometry. So, by using the SOHCAHTOA rules, sine of the angle equals opposite over hypotenuse. So, sine of 57.83 equals y over 29.04. Y comes out to be 24.586. Then, through the same rules, cosine of the angle equals adjacent over hypotenuse. So cosine of 57.83 equals x over 29.04, and x comes out to be 15.465. So looking at the horizontal components, at the minimum, where x equals 22.7, the velocity is 29 meters per second. And at x equals 23, the velocity equals 15.465 meters per second. Then we look at the vertical component. At the minimum, x equals 22.7, the velocity is 0, and at x equals 23, the velocity equals 29.586. So this next step is to find acceleration. So to find the average velocity, 29 plus 15.465 divided by 2, the velocity comes out to be 22.23 meters per second. By using the same rule in the vertical component, the average velocity is 12.29 meters per second. So to find the seconds, we have to know that the distance that the coaster travels is 3 meters because it is 230 minus 227 because the units of the coaster is 10 meters. So 22.23 meters per second times however many seconds is going to give us that 3 meters. So we divide 22.23 from both sides and find that seconds is 0.1345 seconds. And in the vertical component, the seconds is going to be the same because it's the same coaster traveling on the same track. So next, to find the change in velocity, it's very simple. You subtract 15.46 from 29 equals 13.4, and then 24.586 minus 0 is still 24.586. And then the last step, to find the acceleration, you take that velocity divided by your seconds, and you get 100.7 meters per second squared in the horizontal direction, and in the vertical direction, you find 182 meters per second squared.
Mike. Thanks, Mike. So we found that the horizontal acceleration was 100.7 meters per second squared, and the vertical acceleration was 182 meters per second squared. But what does that actually mean? Well, we found the vector to find that overall acceleration was 208 meters per second squared using Pythagorean theorem. So what does that mean? Well, we know that 1g is the amount of force acting on us on Earth, so we wanted to figure out how much of that is acting on us with 208 meters per second squared to find out how much is survivable. So we divided 208 meters per second squared by gravity to find that there are 21.2 Gs acting on you at the most extreme part of our roller coaster. But what does that even mean? Well, let's take it away with Mike.
So,
It's not on.
as you can see from this graph, it charts the survivable amount of G's per time. So we found through differential calculus that the time change is about 0.1 seconds. And this G's will be felt in the reverse and upwards direction, which are the red and blue lines here. And so at 0.1 seconds, we would assume that it would be in between these two lines. And either wherever it is along that line, it is going to be above 21.2 Gs, meaning that this natural selector is survivable. And back to Nick.
Thank you, Mike. So in conclusion of what Mike just said, the survival amount is somewhere around 30 Gs for 0.1 seconds, so everybody aka the natural selector is completely survivable.
Some side effects of this roller coaster include
Erectile dysfunction,
Circulatory defects, hypertension,
ruptured capillaries,
loss of eyesight,
disrupted respiration,
fainting, musculoskeletal pain,
paralysis,
lung clouds,
erectile dysfunction,
stroke,
erectile dysfunction,
increased blood pressure.
involuntary muscle contraction,
and death.
Do not ride this coaster if
You're pregnant and nursing?
have any sort of pre-existing condition whatsoever.
You are under 18 years of age or over 35.
Like we said, this coaster will weed out the strong from the weak, so if you do not survive, you are not prepared to continue in humanity's reproductive existence.